Hi, this is the initial presentation introducing Ariel, the engine for automated test cases generation and execution based on requirements. I am Mykola Kolesnik and I'll lead you through that. In this presentation, we'll cover the following topics. Firstly, what is the Ariel in general and what place it occupies? Secondly, its main principles and ideas explaining how it works. Then major ways Ariel is supposed to be used. Then we'll make some overview of features included into engine. And finally, we'll cover the ways of further growth and directions of development, since this application is still under development. During test automation development, each feature goes through the following stages. First of all, its requirements definition, the stage when we collect, formalize, and describe requirement behavior of the system under test. Second stage is test design. Once we define how a system is supposed to work, we identify typical test scenarios we want to check for correctness. And finally, automated test implementation. It's the actual coding to make test cases executed by some specific software. In general cases, all those stages are sequential. Thus, we cannot implement automated tests before we define test scenarios, and we don't start test design before we define what is exactly required. This is classic flow from requirements definition to automated test implementation. As it's seen, it's time consuming, and if all of the stages are done in different streams, and usually it is so, there are some points of time when some stream just wait for input from previous streams. How can it be improved? A lot of modern test automation tools and frameworks implement keyword-driven approach when some human-readable text is associated with some portion of executable code. This approach is now supported both by vendor tools like QDP, Test Complete, etc., as well as a lot of engines are designed to support this approach. For instance, Cucumber family, Xspec family, whatever. All of those solutions are targeted to combine test design stage with automated test implementation. Thus, we are getting some time savings due to some activities are done in parallel, and each stream has less time when they are simply waiting for the input from the upstream. Also, keyword-driven approach resolves the problems with synchronizing test cases with their automated implementation. Since automated tests or executable chains are generated based on tests designed, we always know what our automated tests are in line with the test cases. But again, we still have to wait for requirements to be defined before starting working on tests. What if our test cases are generated based on requirements or specifications we define? Thus, we can make all our stages running in parallel. Thus, the time advantage is bigger. So, the idea is that our requirements are the source for tests and automated test implementation. Such approach is called executable requirements. So, what can make things drive in this way? As it was mentioned before, test design and automated test implementation can be combined using keyword-driven approach operated by tools supporting it. Cucumber is just one of the examples of it, but there are many others. But what about making requirements executable? A lot of tools are considered supporting executable requirements approach, but mainly all they provide is an ability to define test scenarios somewhere within requirements with additional ability to run those tests. It's not really executable requirements, but rather another form of linking tests to requirements. What I'm interested in is an ability to generate tests based on requirements so that any requirement change will automatically affect changes in test cases as well as their automated implementation. This is what Ariel is designed for. It is targeted to collapse requirement definition and test design into one stage, or at least make them running in parallel. And the output of Ariel then can be used by keyword-driven engine as in this area existing solutions are handy enough nowadays. Thus, we can explicitly define main purpose of Arial engine. It generates test cases in controlled way based on requirement specification descriptions. In order to have an idea how it works, we should know the following items. Key principles we should keep for requirements design, typical patterns we use for data and test scenarios generation, and the general flow the Arial use for scenarios generation. All scenarios generation is based on several main principles. They are: typical functionality requires typical tests. It means a lot of components work based on similar principles flows. Thus, it can be defined in common way. Second, in most cases, we choose test data having knowledge of acceptable format, set of available records, or any kind of data relationship. So, we can define just rules and the engine generates a set of all input data without any explicit definition. And third, each test scenario goes through some specific stages. They can be represented in some common form, hence that part can be automated. Next slides will describe above principles in more details. A lot of applications under test functionality may be different by the data they operate and the way to reach the checkpoint, but they may have similar approach for test design. In this example, we have two different forms. One of them submits user information, another one submits price and due date if applicable. Both forms operate with different entities in different format. Nevertheless, both forms have similar test types. Firstly, valid input. It means all data fit the format and all fields that are set. The result should be success. Second, some data has format violation. Thus, we expect some failure. Some fields are mandatory. So, we have some items empty and we should have some errors due to that. And finally, some fields or combination of fields can be unique. So it means that if we play the same scenarios twice, we are getting error because uniqueness was violated. As you can see, the above test scenarios can be applied to both forms. Major details are about operation flow to reach the form actions to perform on form data and results verification. Major difference here in this particular example is that, for instance, unique field scenario is not applicable for second form as we don't have unique fields combination, but the main thing we should notice is that the types of test scenarios are pretty similar. We can even abstract from web form and apply similar approach to something else, like command line utility, web service, whatever. The form can be different, but techniques are still the same. Imagine we have some field which fit the format defined on the slide. Here it is an example of the phone number format. The test data for any input like that is quite typical and can include groups like: firstly, values matching the format, one or two values that fully satisfy the format. Maybe it is used for positive tests as valid input. Second group is malformed format. Normally it can be achieved by concatenating generating strings for valid input. Also it can be included with the empty values, or value which doesn't meet input data requirements. Example, format expects numbers, so we should enter alphabetic characters. Main idea that all the above groups can be generated using predefined algorithm for the specific input type. Thus, in our requirement document, we can use only format description, which is much more compact record than any set of potential input values. Here are just some examples of input data format definitions. Mainly, format can be based on some regular expression or some constructions in the predefined format. Here are examples of any text string without restriction. In real life, usually there is at least size restriction. Numeric range. Having data defined in this format, we may use not just positive-negative techniques, but also boundary value analysis. Same range, but for dates. And enum, which defines just some set of available values. Most of test scenarios can be represented in the form action result. In order to make a distinction between positive and negative tests, we can represent our test as an action, a result on success, and action, a result on error. Every test case may have some preconditions, and all this structure may be driven by some set of input data. Since these items are pretty abstract, here we can freely apply this to many test cases and find all those structure components in any of them. The Arial uses this representation for test scenarios generation. In order to explain how Arial is used, we need to explain in more detail the following items. First of all, its major flow, the high-level flow which is used to transform requirements document descriptions into tests and their execution results. Secondly, it is Arial processing flow, the flow showing how document is internally transformed into Cucumber features. And finally, it is sample code. Simply shows an example how Arial instructions are bound to test class. Major Arial flow involves three major components: Arial itself, Cucumber as an engine running generated features, and JUnit as immediate test runner. The flow itself goes in two stages. Stage 1 is initial requirement document is represented by Arial, and the output Cucumber features are written into some resource. Once we have a Cucumber feature generated, we can go to the second stage, when Cucumber features are taken by Cucumber and being executed using JUnit. This is the stage 2. As the result, we have test reports containing generated test scenarios results. Arial itself processes documents in 5 major steps. First of all, we are reading a document from the specified source. It's not necessarily some file, but also it can be some other source like Jira or any other remote website. The main thing is that eventually we should get some text representation of requirements. After that, engine packs items into some specific structure and parses them, retrieving all necessary data to any required items. Then, based on parsed data, we generate our input, which we are going to use in our tests. Having test case internal representation and test data generated, we generate Cucumber features with multiple scenarios based on some specific algorithm. And finally, when we have such representation, all we need to do is just write result to some specific output. It's not necessarily a file, mainly it is file, but the output may be different. Here is Arial test class example showing how it is included for real-life tests. As you can see, it's a simple JUnit test without any methods with it, and we are using just annotation. There are 3 points where we should make additional settings. Firstly, for any test class we should make sure that Arial Runner is used for JUnit tests. For this purpose, we use run with annotation. Secondly, we should define Arial configuration, where we define where we take data from, the format of input-output data, and the destination. This is done using Arial annotation. And finally, Cucumber annotation. Since the Arial simply prepares the input for Cucumber, we still should use Cucumber annotation to provide all information which Cucumber needs. Here is the list of major features of the Arial. Firstly, it is initial integration between requirements and tests. So it means that our requirement document is the source for test generations. So if we change the requirements, tests are updated automatically by design. Second feature is that we support multiple data sources, and the engine is initially designed the way that we can add any data source we want at any time. Another feature is that Arial can be used in different ways. It is provided as a command line, it can be used as a library, or it is provided as a Maven plugin for initial generation. Another feature is extensibility and customization. Since we are not restricted with input-output sources, we should provide an ability to provide either our custom data sources or custom algorithm for data generation and processing and scenario generation, or we should easily extend any existing functionality to add something new. And finally, as it was seen in previous slide, it is quite simple to use because all we have to do is just to add some additional annotation. And then we should write our requirements just in some specific format. But the idea and the way of using is pretty simple. Of course, Arial isn't something static. It should grow in many directions. There would be a lot of internal improvements related to scenarios generation or extensibility. But external growth is targeted to 3 major directions. First of all, it's input sources support. The Arial should be able to read not just from text files, but also many different tracking and documentation management systems. It can be Jira, Confluence, GitHub, Wiki, or some external web services. In any case, we should integrate Arial with many external systems where we can store initial requirements. Secondly, at the moment, Arial is designed for Java, but in order to make it more universal solution, it can be migrated to other development platforms and technologies. Mainly, it's about migration to different programming languages. But since main development is done for Java, we also should be able to support various Java engines. In particular, Arial shouldn't be strictly bound just to Cucumber. We should be capable to configure it to JBehave. Also, it should be runnable not only just for JUnit but for TestNG as well, as many people use TestNG. Currently, Arial is provided as Maven dependency as well as plugin. Similar things should be done for other tools performing dependency management or build. Just an example, Gradle. This is pretty it. All project relevant information can be found using the links on the above slide. They are: firstly, it's a GitHub project. Secondly, it is a Blogspot page with entries dedicated to Arial. So please, if you are interested in this project, you can take a look at posts in that direction. or you can contact me directly using my public LinkedIn profile or personal email. Here is the time for questions. That was a presentation of Aerial. That was just a brief introduction for it. I am Mykola Kolesnik. Thank you very much. Thank you for watching, and see you next time.